Hi folks, we're going to take a look at number 9 from the Unit 5 assignment. So they're asking us to sketch this quadratic function using the step pattern. Okay, so the first thing we're going to do is determine what the step pattern is going to be for this function. So the basic step pattern is just 1, 3, 5, 7, and so on. And so the step pattern for this particular function is just going to be the a value times each of these numbers. Okay, so -2 times 1, -2, -2 times 3, -6, -2 times 5, -10, and so on. Probably don't need to go any further. Okay, so I can start directly on the graph, but in order to be able to know what the scale should be on the graph, I'm actually going to write out a few points. Okay, so in order to use the step pattern, we always start with the vertex, which in this case here is going to be -2, 8. So here, -2, 8. And the way the step pattern works is as I increase x by 1, these numbers tell me how much the y values are going to increase by. Okay, so if I go to the next point, if I increase x by 1, so that gives me -1, the y values are going to go down by 2. So 8 minus 2 is 6. Okay, and then let's do another point. If the x values go up by 1 again, so if I go to 0, now the y values are going to go down by, the next one is 6. So 6 minus 6 is 0. So passes through 0, 0. Okay, and I'll do one more. I don't know if I'll have enough room to graph it. So here the next one is, again, if x goes up by 1. Okay, so 1. Now the x value is going to go, the y value is going to go down by 10. So 0 minus 10, -10. So these are 4 points on the graph. Now, of course, we're going to use the symmetry of the quadratic function to draw some other points. Okay, so I look at my x values. They go from -2 to 1, but I'm also going to go on the other side. So I'm going to try to place the -2 where the vertex is, somewhere in the middle of my graph. All right. Now, if I look at the y values, they go from 8 to -10. So that means I'm going to put my x-axis, somewhere in the middle. Okay, so here's my x-axis. And since I want the -2 to be sort of in the middle of the graph, I'll put my y-axis a little to the right. Okay, so here we'll go up by 2, 2, 4, 6, 8. Okay, and then we'll hear -2, -4, -6, -8, -10. Okay, so that's as far as we need to go. And then on the x-axis, I'll go up by 1. Okay, so we have 1, 2, then -1, -2, -3, -4. Okay, so obviously if you're working with a grid, you can be a little more accurate than this. Okay, so I'll start with my vertex, -2, 8, so -2, and here 8. Okay, my next point is going to be -1, 6. Over here, my next point is going to be 0, 0. Okay, and the next point is going to be 1, -10. So all the way down here. Okay, and so we see that we can draw the right-hand side of this parabola. Okay, so that doesn't look too bad. But then, of course, these points also have their corresponding ones on the other side of the axis of symmetry. Okay, so here we have that one there, this one here, and then here we'll have at -10. Okay, so we can draw the the left-hand side of this parabola. Okay, and there we go. There's a fairly decent graph, especially that I'm not working on a grid. If you're working on a pre-prepared grid, this should look even nicer. All right, so just to recap how this works. So the idea here is that the basic step pattern for a quadratic, so if I'm looking at, y equals x squared, our basic quadratic function, our step pattern is 1, 3, 5, 7, 9, and so on, essentially all the positive odd numbers. And then to find the step pattern for a particular quadratic function, I just take the a value and I multiply to each of these. And the idea is to start with the vertex and then move the x value up by 1 for every step. And then these numbers here tell you the change in the y. So in this case here, it's a downward facing parabola. So the y values are decreasing from the vertex. Okay, and the only other thing to talk about is to make sure that you're choosing your scale so that it fits the points that you're working with. Okay, that's it for this one.